Radio guy here. I wanted to upload a video today, and it's going to be about Coax. When you design your radio system for your home, business, or in your car, I wanted to talk about how much the coax matters that you use for your system. We're going to go ahead and get started with the presentation. I hope you like, subscribe, and enjoy the video today. Choosing the right coax. Coax has an outer jacket. It's called a thermoplastic outer jacket. They're black. They're usually UV rated. Some of the coax it's white you might find for a discount on the outside. A lot of those are only indoor rated, so be careful. When you're buying your coax, make sure you get the black jacket thermoplastic outside. So next we have the braided shield. You can tell the different levels of the coax and the quality of them from the shielding, how well and tightly that braid is woven around there for insulation. Some of the off-brand of coax, you're not going to have a real nice braid on there. So it's really important to take a look at what you're buying, look at the schematics of it. The dielectric is an insulator that insulates the center coax from the shield. You don't want the center coax to ground out on the shield. Some people have magnetic mount antennas on their roof, and then the coax goes through the door jamb of their vehicle, and every time they slam the car door, the coax gets pinched and pinched and pinched, and finally the shield on your coax can ground out to the center conductor, and that's not good. So a good dielectric is ideal. The foil shield goes underneath the braided shield. Not all the coaxes have this. LMR brand of coax, they always have the foil shield. The RG coax doesn't always have the foil shield, and that just adds another layer of insulation. It prevents loss and also interference from outside sources. So if you have your coax running next to your microwave or some other device in your home that might cause interference on your receive and transmission line, that foil shield is really going to help cut out that interference. You can have either a stranded center conductor or a solid center conductor, and it depends. Sometimes the coax has, you'll see something called Ultraflex, and that it's a stranded center, or a U as a designator in the name of the coax. That's a stranded center core, makes it more flexible. All right, here's a cutaway view. We start out again with the thermoplastic outer layer, and then the shielding, then the foam. Dielectric, what that dielectric means is it's just non-conductive. So you're not going to have any conductivity. You're not going to have energy from the center being transmitted through the dielectric to the outer shielding. It's meant as an insulator. One thing that can happen, though, is water can get down inside your coax. And if water gets inside your coax is shot. You have to replace it. There's no way around it. You just have to replace it. What's going to happen is it's going to hold that water inside your coax, and it'll ground out your shielding to your center. So when you do installations outside on your roof, or if you have connectors outside of your vehicle that screw on the bottom of the antenna, you want to make sure that you seal that up with tape the best you can. And I have that in one of the other videos you can take a look at. This is an example. I think in the picture here we're looking at LMR 240, and you can see how tightly that shielding is braided, which is excellent. Then we have the inner shield that is just that second barrier to prevent loss and also to prevent interference from getting into your coax, your center conductor. Here we have 5 different types of coax, and I cut away the center of the coax so you can see what you're looking at here. The first one is RG8U. RG8U, over 100-foot run. So if you have 100 feet of coax, it's gonna have 4.1 decibels of loss. We'll explain what that means a little later. But the shorter you cut that cable, the less the loss will be. But the properties that make up the cable, how thick the center conductor is, how good the shielding is, and how good the material is on the inside is all going to dictate what the decibel loss is per 100 feet. And that's how coax is measured. RG8 is the same thing, only it has a solid center conductor. It has about the same loss, negative 4.1 dB, minus 4.1 dB of loss. LMR 240, I really like LMR 240. It's only minus 5.2 decibels of loss per 100 feet, and it's a lot thinner than the RG8. So your pretty comparable on the decibels of loss, and you're working with a thinner coax. It's easier to manipulate. It's easier to push through walls or up through your attic. It's a little bit larger than maybe your TV coax, but it's pretty similar in size. LMR 195 is pretty darn small. I use this in mobile radio installation sometimes. It's smaller than the LMR 240. The loss is going to be higher because as that center conductor shrinks in size, their loss is going to go up. So that's negative 7.76 decibels of loss. And lastly, we have the RG58U. This is what typically comes on a magnet mount antenna, is minus 10.6 dBs of loss per 100 feet. And I do want to clarify, the frequency you're transmitting on affects your decibels of loss. The higher the frequency, the more loss you're going to have per 100 feet of cable. If you're down on 27 megahertz where CB is, the loss is going to go way down. So for CBs, you could use RG58U for a long run, and your loss is maybe only going to be very minimal. But when you get up to GMRS and ham radio frequencies at over 400 megahertz, GMRS is at 462 megahertz. That's how I calculated these. So at GMRS frequencies, 462 megahertz, if you use RG58U and you're going 100 feet, you're going to have 10.6 decibels of loss, which is huge. I have provided a cutaway view of all the coaxes. That way you can see, and there's even a penny in the picture, so you can see how thin that center conductor gets. And I've added something called Heliax. This is what I use at my home when I'm using 400 megahertz. I use half-inch Heliax. It's kind of like a water pipe. It's the copper. It's almost a solid copper outer shield with a huge center conductor. The loss per 100 feet at 460 megahertz is 1.46. It's very minimal. If you can afford it and you have the space to use Heliax, it's kind of cumbersome. It's hard to use. It's hard to bend. You can't bend coax at a hard 90 degrees. You need to have sweeping corners. So if you have room to use it and you can afford the Heliax, this is by far the best way to go. Next, we have the RG8U with the minus 4.1. You can see the U designator in the name, and then you can also see on the picture, it has the stranded center conductor. It makes it more flexible. There's also the foil shielding and also a nice tight braid around it. The RG8, it still has the foil shielding. It has the braiding around the outside of it. The center conductor is solid. I like solid conductors better just because it's easier to put the ends on the coax. If you're going to be making your own cables, solid conductor is much easier to manipulate and putting your own ends on. LMR 240, it's the one that I like for a lot of occasions here. This is a minus 5.2 decibels of loss. You can see how substantially smaller the center conductor gets from where we started up at the top with a half-inch Heliax. And these loss levels are going up as we go down in size of coax, because we're talking about 460 megahertz here. LMR 195 is minus 7.76 decibels of loss. And then we have the RG58. The center conductor of that RG58 is thinner than a strand of uncooked spaghetti noodle. If you've ever seen that, the hard noodle, it's smaller than that. You're talking about a very, very small wire. It has huge losses, and you all can also see from the picture, there's no foil shielding around the dielectric in the coax. All these cables are 50 ohm cables. They're not the same as your TV coax. Your TV coax is 75 ohms. I have heard of people using TV coax, which is like RG6. They sell it at Walmart and Target, and you can buy it just about anywhere. And just like everything else, there's different levels and qualities of TV coax, but it's 75 ohm. I've been told by an engineer it won't damage your transmitter, but what's going to happen is when you're using 75 ohm coax, it's going to significantly increase your losses. Your decibel of loss per 100 feet is going to skyrocket. So it doesn't make any sense to buy a nice radio, buy a nice antenna, and then put the wrong cable in, and then all of your signal gets bled out through the cable. It makes no sense to me. So I've created this illustration to help you understand what we're talking about when we're talking about decibels of loss. So on the left side there, we have the received signal strength. This is where your antenna is, all right? So your antenna is on the left side, and on the right side would be where your radio is, and in between those 2 points is 100 feet of coax. When you listen to the radio, there's something called the noise floor. It's where the static is, and it's really hard to distinguish signals when they're in the noise floor. The red line, the minimum receivable signal level, that's the level where it's just above the noise floor. It might be hard to hear. You might have a lot of static. You might have to put your ear down next to the speaker to make out what they're saying. If the signal goes below the red line, then it's going to be very difficult to hear what they're saying because it's right in there with the static. All right, so there's our signal. Our signal came in, boom, it's a green ball of energy and it hits the antenna, kind of a medium signal. And then the signal is going to be going down the coax, which is green, to the very end where your radio is. And on this example, we'll say it's RG8U. It's going down and we have minus 5 decibels of loss. So we have 100 feet of coax and we're losing 5 decibels by the time it gets to our radio. It's still above the minimum receivable signal level, so we can hear it just fine. It may not be the strongest signal, but we can hear it and we can make out what they're saying. All right. Here's the same example, only this time we're going to have negative 10 dB of loss. Maybe we used RG58, which is the really thin coax. We ran at that same 100 feet, and at the end we have our radio. That signal comes into the antenna with a medium signal strength, and it could be heard just fine on the other coax, but now that we're using RG58, because we have 10 decibels of loss, when the signal reaches our radio, it's below the minimum receivable level. That means we can't hear it. It's too staticky. All we hear is static. The signal's not coming through to our radio. We hear no noise on our speaker except for static. Let's reset and we'll do one more example. We're going to do the same coax, the RG58, the really thin stuff, but we're only going to run it 50 feet instead of 100 feet. Because we're cutting the cable in half, instead of 10 decibels of loss, now we have 5 decibels of loss. And it's only 50 feet long. Well, because we did that, we don't have as much loss, and now the signal is above the minimum receivable signal level. So we can hear the signal. It's going to be a much weaker signal than the RG8 coax, which only had minus 5 dB, but we could still hear it. So I hope this is a good illustration to help illustrate why the coax matters. Now, we talked earlier about a magnet mount antenna. If you have a magnet mount antenna and it has RG58, which most of them do, and you're operating at 460 megahertz, which is a higher frequency, the magnet mount antennas only have 15 feet max of coax. So at 15 feet, you're not going to have a really distinguishable loss level. Even though you're at a higher frequency and it's a high loss coax, because you're only doing 15 feet, you're going to be able to hear things just fine. Now, if you mount that magnet mount on the back of a 100-foot truck, right, and then the coax goes along the 100 feet of the truck, or you weave it through the frame rails and you go all the way up to the front, and maybe you have 30, 40, or 100 feet of coax, that's going to significantly degradate your signal. And maybe the magnet mount, you weren't able to use a 100-foot cable, so you have to use a connector to splice the coax together. Each of those things, each of those adapters, each of those connectors that you add onto your signal is going to add more decibels of loss. So if you can get by with one piece of cable unspliced, that's your best case scenario. Cable loss also affects your transmit power. On this example, on the left side, we have the transmit power wattage. So for our example, we're going to be using a Kenwood 8180 radio. It's a commercial radio. These things are tanks. If you can get your hands on one of these for GMRS, it's fantastic. The only downside is it doesn't really do ham radio that well. Only the higher frequencies in the 400 megahertz range. You can do some repeater work. All right, so this radio has 30 watts of power. And you can see our little ball of energy there. That's a green bubble. And that's going to be our 30 watts of power. Boom, there we go. You follow that transmit line down the 100 feet of coax. And again, we're going to be using RG8. And we have 3 decibels of loss. It would actually be 4, but the rule of thumb for this is for every 3 decibels of loss in your coax, by the time the energy reaches your antenna, you're only putting out half the power. So right now, after 100 feet run of coax, you're only putting out 15 watts to the antenna. Your radio is putting out 30 watts. By the time the energy reaches the antenna, it's only equivalent to 15 watts. And that's with nice coax. That's with RG8. Now we're going to be using RG58 with 10 decibels of loss. If you're using RG58 on 400 megahertz, 100-foot run, you're putting 30 watts into the antenna, or 30 watts into the coax. It runs 100 feet. You're only going to have 1/10 of the power of when you started. That's 3 watts. So you have a mobile radio, you think you're doing great. You have 30 watts of power, but really going out of the antenna, you only have 3 watts. That's pretty remarkable. Choosing the right coax for your installation is key. You can put all the money in the world you want into your radio. You can have $1,000 radio, $5,000 radio, and you run RG58 coax to your antenna, you're only putting out 3 watts. Put your money into your coax and your antenna. All right, so here again, we have the RG8U, RG8, LMR 240, LMR 195, and RG58U. I sure hope you guys enjoyed the video today. I hope you learned something. Be sure to like and subscribe to the channel. Write any comments that you have, and I'd love to get back to you and hear what you have to say. This is the radio guy signing out. 73.